All right, so we're in week 5. I did a couple things today over the weekend. I changed your syllabus. I actually don't recommend printing the syllabus. You can. It's probably going to get changed again in a couple weeks. When I wrote your syllabus, I had never finished it. The first 2 days of class, some things happened, which is like 12 of you added the class in the first 36 hours, and I was a bit overwhelmed, and I never actually finished your syllabus. And I was looking at it this weekend, and I don't know if anybody noticed the original syllabus, there were pieces missing, and there was actually, you probably didn't notice, there was a lecture missing. And so this week, I don't know if this week changes, but I look at these next 3 weeks because they're the reaction weeks. And so the next 2 weeks, we pretty much do a study set, a lecture, study set, and lecture. I moved the celebration, had it on Tuesday, and I moved it to Thursday because there was a lecture that it allowed, I know what it was, it allows me to do a review day in there, which I've never done before. And I think that in this environment, being on Zoom, that we need the review day before the celebration. And so I just want you to be aware of that. Another change that I made is I had to renumber the labs because I was confused what lab we were on. So since the peer evaluations are the same amount as the labs, that's just in my mind how it works. The points are still the same, how they were. Next week, this was on your syllabus, it just had the wrong date. I just have to confess this because I was looking at the Nepalese calendar, and Nepal is 12 hours different from us. And so in Nepal, Sherpa New Year is on the 12th, but in our country, it is on the 11th, which is next Thursday, biggest holiday for Sherpas. So there's going to be a lot of food in my house on that day while I'm teaching. Anyway, there's going to be a bonus lab that week. There's going to be a regular lab and a bonus lab, extra credit bonus lab that you get to do in your own kitchen. And so I'll be posting that sometime this weekend or next week. But because bonus points are worth it. It's a fun lab. I'm doing it with all my classes. There was something else. Oh, the innovation presentations. That's the thing that might change. I haven't decided when I want to do it. It will be after the next celebration. But I had originally said you're going to do presentation probably on a famous chemist, but my other class did innovations. And since we're going to get into thermochemistry, and actually a lot of the problems that we've created in our environment has to do with thermochemistry and combustion and stuff. My other class just did where they did on current events. So innovations, ways to deal with, to move forward into a better future. And it was really fun. It was really inspiring. Like everybody did something different. And so if you find something really cool and you want to research it more, you can send me an email, but I'll talk about that more as the weeks come. There was something else, but I don't remember now. But I just wanted you to know that because I really can't stand Blackboard. Blackboard apparently notifies you every time I touch Blackboard. And I don't know how to do things in secret, but I apologize for that. All right, so the first 2 pages were pre-videotaped. Hopefully you did them. These were the notes that went along with them. So we're good. We're done with those notes. So apparently we have page numbers. I don't know where they came from, but we're going to be doing stoichiometry. So this is great news because there were a couple of you who are like, I really like the reactions because we didn't have to do any math. We were doing math, but we're doing factor label. This is the whole point of why we learned how to do factor label is for tonight's lecture. For those of you who do not like factor label, you're going to be grateful because it makes tonight's math much easier. So stoichiometry is doing math with chemical equations. So it's the math of reactions. For those of you who learned how to do factor label, like in a math class, The whole reason anybody has factor label is because of chemistry, because of these equations, and then it became adapted to other things. But we are going to be on Thursday writing chemical equations. So this is number 1A as a prelude to it. So we're going to combust sugar. This is what is going on in every cell in your body right now. In all of us is blood sugar is glucose. It is our energy. Now, something I mentioned, we are going to show states of matter. We're going to come back to states of matter at the end after we do this because it made me realize something. So you all know this. Combustion means what else has to be present?
Oxygen.
Oxygen. Combustion always means plus O2. And then you put your arrow. I recommend when you do your plus that you leave a space because we're going to have our coefficients, our coeffish. All right. And the oxygen is really greedy, right? It has a halo. It's going to combine with the carbon and it always makes, this is like the problem, CO2. For you and me, we breathe it out. The trees breathe in our CO2. It's just our cars and everything make a lot more CO2 than the trees can handle. The hydrogen and oxygen combine to make what?
Water.
Perfect molecule. Of course, it's water. And then we're going to balance. This is where the colors help. Now, you can put the little blanks in front. You don't have to. That's a student showed me that, and I started teaching with the blanks, and it was a game changer for the students who had trouble. Some of you are going to be able to do it without the blanks. You don't have to put the blanks there. I'm going to do it for this one just to show you. So we're just going to go start with the carbon, 6 CO2s, hydrogen, there's 12, so 6 H2Os. Now, this is an interesting combustion because sugar, one of the issues with burning sugar is some of the oxygen has, some of it's already been oxidized. It's already got oxygen with it. So if we count our oxygens, we have 6 times 2, 12, plus 6 more in the waters. So we have 6 from the, 12 from the CO2s and 6 from the waters. So over here, I already have 6 in my glucose, so I need 12 more. So I only need 6 O2s, because that will give me 6 plus 12, and I'm balanced. And then you leave this blank or you show your 1. Now, states of matter. We are going to be putting states of matter in this class because they become a really big deal next week with what we're doing next week. So combustions. Combustions mean everything has to be a gas. For your car to work, the gasoline that you put in, even though it's a liquid, it has to be heated up to the gas state. So if you want to go with that and say for combustion to happen, everything is a gas, you can absolutely do that. I'm having trouble doing that because I'm a biochemist, and in our body, our body is not a combustion engine that heats sugar up to combustion, or else we would explode. So this would probably actually be aqueous, but we're going to go solid gas, and we don't make H2O as water vapor. We make H2O liquid. What most students do is they just go with, oh, I like that thing where I just make everything a gas for combustions. That's only for combustions. And we'll talk about states of matter more next week. But I wanted to introduce the idea right now. All right, the math. And this is where those of you who do not like the factor label are going to suddenly go, oh, this is not so bad. So glucose is the C6H12O6. And we're solving for grams of water. So it's really nice to write down where you're going, grams of water. Right, and these are all factor label. So first step is what chemists love to do. Go to moles. That's really our central theme here is we're going to moles. Now, the key with doing these is not to be lazy. Everything has 2 units. In stoichiometry, everything has 2 units. So you have moles, but it's moles of C6H12. So our first step, we're going to add up the number from the periodic table. I should have these numbers. It's 180. Really? Let's just go. It's around 180 point something. I don't know, say 0.1. It might be 0.2, but just for time. So we have to change 2 units. You can only change 1 unit at a time. So we're going to change grams to moles. And this is the key to stoichiometry, is this step. This is really all we're learning tonight, is this middle step here. That you pull that unit down. And actually, you've all got that idea of changing units. And then we're only changing 1 unit at a time. So here I kept the C6H12, but I went from grams to moles. Now I'm keeping moles. I'm doing a mole to mole ratio, and I'm going to change it from the glucose to the H2O. So all of you should be going, we did mole to mole ratios before. We're just now doing them with the balance equation. This is the coefficients, or the coefficient. So that's where that 1 here is really nice. For every 1 mole, you get 6 moles of H2O. Those are always from the balanced equation. They only show up in that step. It's the middle step. It's really nice. Your study set. The nice thing about the math study sets, they're actually much shorter because I have to give you lots of space to show your work. So there's only like 4 or 6 questions on there. All right. And then we go back to grams. When you go to grams, it is always just 1 mole. When you use the periodic table. So where I got this 180 from is from the periodic table. I added up the 6 carbons, the 12 hydrogens and 6 oxygens. Same with hydrogen and oxygen in the water. We'll get around 18. You can say 18.02 or 18.016. That's kind of however you want to do the periodic table. I ask that you use 4 sig figs with the periodic table because it does make a difference, and we'll get that number. That's it. That's what we're learning tonight, is this mole to mole step. All of these are going to be looking the same. So the next one, underline your piece of information. That's your starting point. Give myself more room this time. The glucose is the C6H12O6. You have to write your compounds. You have to have the 2 units, the gram or mole, and that's make your railroad tracks. And then write down where we're going. Oh, we're not going to grams. We're going to go to molecules, and not just molecules. Write the whole word, CO2. You can leave out the of, or you can show it. That's not a big deal. To get to molecules, we're going to get to use, let me give you a moment to try it. I'll say the ABCs backwards. And if you don't want to try it, try and balance an equation. So I'm going to pause. Let's go ahead and keep going here. So our first step's the same. Oh, go ahead.
Oh, no, I was going to say I got your answer.
Oh, I know my answers are good on this handout. I think this was the first set of notes I ever made. Actually, Major, you did this page of notes with me before.
Yeah.
You still have your notes from 2 years ago. You
Oh.
have this page of notes. There might be a few things different, but these two questions is how I always start teaching stoichiometry. And so change your grams to moles. Again, this step is from the periodic table, adding up your carbons, your hydrogens. I'm just writing this as a note to just make sure. So whenever we start with grams, change your grams to moles, periodic table. And then this next step, pull down my mole. Notice I don't pull the number down, I just pull the unit, both parts of the unit, and I'm gonna do a mole to mole ratio. So that's why I like to write where I'm going, because one of the things in a balanced equation, you can go between any two parts of a balanced equation. You can go from reactant to reactant. You can go from reactant to product. You can go backwards. It's just whatever the react question asks you. All right. And then this ratio is our coefficient. So 6 CO2s to 1. So that's our balanced equation. This is the whole point of balancing. Well, it's not the only reason. And then we go back. So they all look, we don't want to go to grams. There is no reason to figure out the mass of the CO2. We are going to go straight to molecules, which is Avogadro's number, 6.022 times 10 to the 23. And please make sure you put a unit on my number. A lot of people forget with Avogadro's number. But there's no reason to go to grams. Once you're at moles, you can go straight to molecules. All right, the equation, balancing it, you're going to need trees in front of, you need 2 in front of the iron. And then this one's kind of keep playing with it to get it to work, but it's for the oxygens to work out, you have to get to 6 oxygens. So it's a 1, 3, 2, 3. And again, if you want to show the 1 there, you can. As this was a harder one to balance. Yeah. All right. It also,
Sorry.
go ahead, Lisa.
If we can go back to C, where you got 6 moles of carbon dioxide. Below number 1.
Yeah,
C.
I know.
Oh, sorry.
6 moles is right there.
Oh, okay. Thank you.
It's from, that's what I was saying. It's the coefficients from the balanced equation. Yeah,
Okay.
as soon as that light bulb, that was beautiful. Great question. And please ask questions like Lisa did, because once that light bulb goes off for this, everything's like, because I know a lot of you are like, the math that gets me, and these all look the same. And the key is they're all going to have this step. So yeah, really good question. So yeah, let's try it with, this one's going to have an extra piece to it. So we're going to start with 150 grams. I like writing them out as words because it helps you to not be afraid. We're going to be writing your reactions as words, and then you guys are going to be putting it to symbols. So we'll start with the 150. The other thing that's nice is I only have this one piece. Oh no, we have 2 pieces of information. Now, those of you who took 151 from me, we're going to do this as one setup. And it wants us to figure out the grams of iron. There is an extra piece, and it is the percent. And I'm going to show you how to bring the percent in as one flow. So our first step, go ahead and do your starting setup. On number 3, if I'm going to show you a different way to do number 3, but you can try balancing if you don't want to try the math, or at least add up your mass of your iron oxide.
Is yield like weight, like grams?
Yes. Yeah, so it's going to be in that last step after you get to grams. Yeah. It can be anything. It just has to be the same unit on top and the bottom, really. So I'm going to go ahead and go through this, just interest of time. You should get 159.7 grams to 1 mole. So the 159.7 is on the bottom. So this is what you don't want to do, is just say grams and moles. Because when you get here, how do you know which mole you're talking about? So it takes what? A whole extra, this is like a meditation I'm giving you all. Do this as a meditation. Do it with love in your heart, and it changes everything. When you approach everything in life as a meditation, that's the key. Major's dad is going to love me because of that. Everything is a prayer and a gratitude. Label, so it's still iron oxide. So now I'm going to make my switch from the iron oxide. This is why I like to write where I'm going to just the iron. In this mole to mole step, when you go from grams to moles, this is the key. Grams to moles, it's always 1 mole. Molecules and moles, it's always 1 mole. The only time mole is not necessarily a 1 is the mole to mole step. And again, this comes from the balance equation. Always look at the balance equation, because sometimes the iron is in different places, but we have 2 moles of iron to 1 mole of Fe2O3. And then, yeah, and back to the question, I think Maddie asked that. This one is worded, it's because we used to use a textbook that you all had to pay like $300, they're $500 now, which is outrageous. And the textbook would word it where they wouldn't say how many grams, but when they ask for yield, they're asking for grams. So in case, hopefully on the study set, I worded it as how many grams. And sometimes, and they would ask, what's the maximum? And that just means what we're doing. So iron is what, 55.85 grams. And again, these are on my periodic table, it's that number down here. Right, this is the atomic number. We're not using those anymore. That was, we get to come back to that at the end with quantum stuff. Label iron over iron. Just make sure everything has 2 units. Now we're going to do one more step because we have to bring the percent in. And this is, we need to be careful with this, and that's on number 3, it's going to be different because it is asking a different question. The percent is 83.70 over 100 or 0.837 over 100. And the way you would label it, they're both grams of iron, but it's actual over theoretic. So on the lab that you guys did this past weekend, oh, that was the other thing on this, on the, that I wanted to mention. So there is always forgiveness with the labs. That's why there's a bonus. There's a bonus again on this week's lab. But I moved the labs, so the labs are going to be due on Sunday. I will have office hours on Saturday morning. A lot of you sleep through. I wanted to mention that on Saturday morning, I actually have a class from 9 to 10. So if you get there early, I will ignore you. So just be patient. Don't come early. Don't come until 10. I teach a meditation class starting this week, and so don't ring the doorbell and interrupt our meditation, but just sit patiently and wait. And I am usually there until at least 11:30, if not 12. But if you sleep through it, which several people sent me a humble email and said, yeah, I slept through your office hour. If you submit your lab before that, like 6, 7 o'clock on Sunday evening, you actually have to submit it. I will look at it. I will write comments to you. I have to give it a grade. There's no other way around that. I will give you a grade, but you can then see my comments. If I don't give you a grade, it turns out you can't see my comments. It's one of those other issues with Blackboard. If you send me an email, I can't write comments on it. It's just how it works. So on Blackboard, I can write comments and then I submit it. You get it, you can go in and look at it, and then you get to resubmit it before the midnight hour. So as long as you get it in, I go to bed usually like before 8 o'clock on Sunday nights. So if you get it in by 7, I can look at it, give you feedback. Now, if you just have like one of those weekends, which happens, and you're like, oh, wow, I really need her help. You come Tuesday office hours and you'll lose 2 points for getting it in late, but there's the bonus, so you can still get all the points on there. All right, you do want to label the A over T. The A stands for actual. The actual is how much you actually get. So in the lab, it was how much copper I actually got. And the T stands for, sorry, I'll write over here. T stands for theoretic. Theoretic means if it worked perfect. It means textbook numbers. So in that lab, I was not perfect. I actually, if you look at the video, at one point, I'm smiling because I considered changing my data to make it perfect. And I was like, no, if you guys were in lab, you would have similar numbers as mine. I think I did pretty good. I had 94%. But that's why on the empirical formula, you don't get perfect 1-2-2 ratio, that it was off. Lisa actually caught it. I think she was right. I think I didn't react it with the zinc long enough. The color was still a little bit there. But she wanted to fire one of the gnomes, and I didn't agree with that. But was he the gnome that was helping me watch the zinc? Is that why you picked that one? That was funny. Some of you write really funny comments in your lab. I appreciate that. All right. Anyway, that's 4 sig figs. Everything had 4 sig figs. All right. On the next one, your balanced equation is, if you want to show the 1, 3, 1, 2. The carbon ends up everywhere. So you have the 1 silicon, the 2 oxygens. That gives you 3 carbons. All right. This one doesn't fall into any of our categories. Again, neither of them did fall into any of our classification categories. It is a Leo Gur. We're not going to do it. Both, yeah. How do I know both of these were Leo Gur? Major, you have to sing to like argon or krypton or something. Halo? Halos over the iron and the copper. I'm sorry, iron and the carbon. All right. The reason I said if you went ahead and solved, this one's a little bit different, and I want to show you how to do it. This one, we're going backwards because it wants us to solve for the carbon. We're going to the reactant. We're starting with the product. So we're starting with, which we can do in the stoichiometry. However, the percent is always of the product. So the percent always goes with the product. And
Wait, how'd you get 3 and then 2 on the other side? Oh, wait, I see it. Just kidding.
the carbon,
Yeah,
the carbon's in multiple places. So you have to be careful with that. I thought you were talking about the 3.00 grams. I'm like, it's right there. So the percent is actually your very first step. If you start with the product, then your first step is the percent and you flip the percent. So you can do 100 over 81.5 or 1 gram theoretic of the SIC would give you 0. If you prefer the decimal, you can do it. Again, you can do it as 81.5 and 100 grams or 1 and 0.815. Again, I see it's like a 50-50 mix. Half of you like to reduce it to get rid of the 100 and half of you like the 100. And that's how you would label it. So if you start with the product, you flip the percent. If you start with the reactant, the percent is at the end. So, and you'll see that in the study set, there's one of each way. And so now the rest is just grams to moles, which is 28 plus 12, so 40.1. Yeah, and so kind of make a note. I unfortunately didn't give you enough room there. And then this is just 1, so we keep it as 1 mole of SiC. I like to write where I'm going, which is back to the carbon, so 3 moles of carbon. Again, back to that question, this mole to mole ratio is from the balanced equation, so the 3 and the 1. The biggest mistake I see with this is not labeling. And the other mistake is people want to put the 3 here below the grams, only the mole to mole step. That is why we have that mole to mole step. That's the only time you bring the equation in, and then you go back to the periodic table. Periodic table is 1 mole, 12.01 grams, and there's our answer. All right, we're gonna move on if there's no questions. Yeah, 2 more pages, but you got the flow of it. So limiting reactant. These end up being students' favorite place for the next, this is usually like where we start for the next celebration is one of these. You're gonna know these because it gives you 2 places to start. And you start as 2 separate we're going to do 2 separate train tracks. So you're given each reactant, given grams of each reactant. And we're going to, so there are at least 6 ways I know to solve these. You're going to all do it my way, because my way requires the least amount of thinking. It works. So the question wanted us to solve for grams of silver. Now, before we can solve, we have to write an equation. On your study set, all the equations are given and they're balanced. So you don't have to do any Leo-Gur, you don't have to do any koi fish. So we're going to solve for grams of silver each time. But to do this, we do need to write a balanced equation. So I only did this one time. It was my first year where I had to do everything on a test. And so I usually have one section of the test is where you're going to write equations, and another section I give you equations and you do the math. Because if you get the equation wrong, then your math ends up being all wonky. All right, so that's the formula for silver nitrate. Silver likes to be a +1. So this is what we're going to be doing on Thursday is writing equations, but a prelude to it. What type of reaction is this going to be? And why?
Single replacement.
It is, Maddie. Thank you. So this is going to be a single. How do you know?
Because it's an element and a compound.
Yeah. So Maddie was in my 151, so she got this. This is what we're doing on Thursday. So you will all by next week, by the end of next week, all Thursday and next Thursday, this Thursday and next Thursday, and the next 2 labs involve writing chemical equations. So you're going to all become so proficient at it, as well as the math with it. The silver and the zinc are going to switch partners. This is actually a tough one to write. I think I actually do this one in the video. So the zinc ends up as a +2. The silver is a +1. I'll talk about that more on Thursday. I want to do the math today. Yeah. I was pondering this today. I'm really used to having 3 hours, and so I'm ambitious with being able to teach some of writing equations here. All right, that's our equation. Just what I want to do, so it's zinc plus 2 silver nitrates, and we end up with 2 silvers plus zinc, and the zinc has 2 nitrates attached to it. That's why I need the 2 here in front of the silver. So what I want you guys to try, and I'm going to pause this, I want you to start with the zinc and solve for grams of silver. And I want you to start with the silver nitrate and solve for grams of silver. You're going to get 2 answers, and then we're going to go through which one is right. I'm going to pause. All right, you can keep working if you're on track. I'm going to go ahead and work through it. Need my table. So zinc, 65.39 grams to 1 mole. Again, if you don't label it with the zinc to zinc, we're going to silver. We're solving for silver both times. So the problem some students have is they go, what about the zinc nitrate? I want to solve this. I don't want the zinc nitrate to be left out. And it's really loving and kind. The zinc nitrate is not being left out. It had to be there to balance the equation. We just don't need to use it in the math. It's perfectly fine with that. All right, 1 mole of zinc to 2 moles of silver. Again, the key, write down where you're going. The problem tells you where it wants you to go. And then whenever you're going to grams, it's 1 mole, and silver is 107.9. Same idea with the silver nitrate. It's like we add up 169.9 grams. And this time we have, so this is a question that often comes up. The last step, so the way I teach it, the last step is the same for both. And again, I do it this way because it requires the least amount of thinking. When you start with the zinc, we get 6.60 grams. And when we start with the silver nitrate, we get the 1.59. So a couple quick things, because we're going to pick an answer. One has to do back here, the mole to mole ratio. I always show the mole to mole ratio as it is in the equation. So I write it as 2 moles over 2 moles. Because I have found when students, one, it helps me to communicate to you so you know where I got the 2's from. And then if you want, you can cross them both out. I recommend you do it that way. What happens is when students reduce as they're putting it in there, they end up reducing one of them and not the other. It is the same as a 1-to-1 ratio. You can write it as 1-to-1. I just see too many people making errors when they do that. And so, all right, you're going to always get 2 answers. And Valentine's Day is also coming up. February is an awesome month. It's always Sherpa New Year, and it's Valentine's Day, and it's Rowdy's birthday, and it's Groundhog's Day, and it's the shortest month. And spring comes at the end of the month. All right, you're going to do an X and an O. And the Super Bowl this weekend. I have no idea who's playing. All right. You're always going to kiss the bigger one goodbye, which means an X. So you always say X, the larger one. You always pick the smaller one. You embrace, you give a big hug to the smaller one. So you always pick the smaller one.
Can I ask why?
Yes. Actually, I was going to ask, does anybody know why? You always pick the smaller one. You always kiss goodbye the larger one. You know that some people probably remember why. And that actually is the key question to this. So what happens when you get to 1.59 grams of silver? The reaction stops. You cannot get to 6.60 because all the silver nitrate has reacted. So this is all gone. That's what this whole math means, is at 1.59 grams of silver, this is all gone. And that is actually half of the answer to the next question. You have 0 grams of silver nitrate left. Because in the next question I ask how much is left over. The silver nitrate is called the limiting reactant. Sorry, right up here. I just say LR. You're going to just see me abbreviate L. Wow. Sorry. It is the one that limits the reaction. It limits how much you can get. When we get to 1.59, it stops. The zinc is called the excess reactant, and that is what part B is. We're going to figure out how much excess. So limiting reactant, you just solved for the same thing twice, and you always pick the smaller one because the reaction stops because you've run out of one of the reactants. So to do part B, again, there are several ways you can do it. There is always 2 answers. One of them is always 0. So this is the limiting reactant is always 0. What we're trying to figure out is how much of the zinc, the excess, is left. I've taught this several ways. That's why I'm pausing. The best way to do it is you start with your answer from your previous one. So that's how I'm going to do it. It's the easiest way for me to teach it. Sorry, I was pondering if that's the best way. Yeah, we'll go with it. So you start with the limiting reactant. So you're basically going from the limiting reactant to the excess reactant. So LR-TER. So we go through the math, and there's always another step. So this part has a couple pieces to it. So the silver, go ahead and set it up. Let's write my first step. So this was my answer. I'm sorry, this is the answer. The 6.60, if you do not cross it out, you're going to try and do something with it. You have to cross it out. You're picking, this is why there have been boxes for you to fill in your answers for the past several weeks, is specifically because of the limiting reactant. You have to put the correct answer in the box, which is always the smaller answer. So you're working, basically you're going backwards, but you're crossing over to the other one. So you're starting with the 1.59 grams of silver, and we're working back to the zinc. Same equation. And then there's another step. So mole to mole ratio, 2 moles of silver, 1 mole of zinc, and zinc was 65.39 grams of zinc to 1 mole. And you get not my answer because we're not done. But you should get 4.82-ish grams. Yeah. All right. That is not the answer. Does anybody remember from last term what that is? Maybe, if anybody's there. This is how much zinc reacted.
Yeah, we will subtract it from the last answer.
Yes. You subtracted from which answer, Omar?
From the last one we pick up from the two equations in the top, from 1.59.
Almost. So
Where's the
what we have to do is we have to do a subtraction. So if this is
Yeah.
how much silver we made, this is how much zinc reacted to make that amount of silver. I have a mistake. Sorry, is it 0. You know what? Sorry. I don't know where I'm getting that number. It's 0.482. Is that what somebody
yeah,
got?
I got 0.4.
Sorry. I know what happened. I wrote on my note really fast and misplaced. So 0.482. This is how much reacted. So from that math, that's how much reacted. The other place you could technically start is with the limiting reactant, because you know that's how much limiting reactant reacted, and work back to the zinc, and you would get the same number. So now what we have to do is we have to take the initial amount of zinc, which is the 2 grams. That was what we started with. And we're subtracting the 0.482 grams of zinc that reacted. And we will get the 1.52 grams of zinc is left. So it's a limiting reactant is you don't mix the perfect amounts. And so one of them always fully reacts and the other one, some is left over. So based on how much you end up with, you can figure out how much of the zinc reacted. When you do this subtraction step, you need to label it. So it's what you started with or your initial mass minus the mass that reacted. Please notice they're labeled, they're both zinc. It's the amount of zinc that started with minus how much reacted, and this is how much is left. I am, just in the interest of time, I will come back and do this. I'm going to show you how to do the next page because this was actually the bonus question on the lab. It's just different numbers, but I'm going to walk through it. And then if you want to stay, I can walk through this problem. I'll actually give you the balanced equation real quick in case you want to try it. So barium phosphate. That's our formula for barium phosphate. Just because of the charges, barium's a +2, phosphate's a -3. And, oh, I'm so sorry. I didn't read my equation. We're doing sodium phosphate. So we're going to end up with barium phosphate. So sodium phosphate. All right, I got caught up with the time. Oh, you know what? I can try and erase. I keep forgetting that I can erase. All right, there we go. So it's sodium phosphate. We have 3.50 grams of sodium phosphate, and it's going to react with barium nitrate. So that's where our barium comes from. So since barium has a +2, I need 3 nitrates. This is the bonus. This is like the bonus on your worksheet today. And the barium nitrate is going to have 6.40 grams. So if you want, you can try this. The reaction, what type of reaction is this? And why?
Double replacement.
It is, because they each have a partner. When you see two, and again, this is what we're going to be doing on Thursday. They each have a partner. They switch partners. So you start with the sodium, and the sodium is a +1, and it now partners with the other anion. So cation goes with anion. If you want, you can show parentheses. but you only, the subscripts, and this is what we're going to be learning on Thursday, the subscripts come from the charges. So that you already know. And then the barium's going to partner with the phosphate. That was me jumping to the conclusion that you need 3 bariums. Too many pieces of paper. And 2 phosphates. A different equation. So there's our equation. We would balance. There's another thing, like it's just with practice, you start recognizing the most complicated piece that you're going to need 2 sodium phosphates. Again, on your study set, all the equations are given. They're all balanced. You're just going to do the math. This was me being eager. I actually have a note to myself that I should have given you the equation. But so there's 2 sodium phosphates, 3 barium nitrates, and you end up with 6 sodium nitrates and 1 barium phosphate. So there's our balanced equation. You're going to solve both times going from your 3.5 grams of the sodium phosphate for the barium phosphate. And same with this. Both times you solve for grams of barium phosphate. And then you pick the smaller number. And which must be this one. This must end up being your limiting reactant. Anyway, so if you want, you can try that. The answers are given. I am hopeful on your study set I gave you answers. Hold on. And then we're going to do the combustion problem. Oh, I did. All right. So yeah, on the study set, I gave you answers. Again, I'm looking that you try them. And so hopefully the study set gives you numbers that you can see, feel refreshed that you got there. Just in the interest of time, I'm going to move on to the next one. But again, here, you're going to end up with 0 grams of the barium nitrate is the other half of the answer. I don't know why I didn't show both parts. And then we're going to do combustion. I did want to make a quick comment because a lot of you, about half of you did this, the bonus question on the lab, or needed some help. The next page, there is actually, there is going to be uploaded another video that's pre-recorded. If you have the time in your life to watch it before Thursday and try this page, those of you had 151, you've actually already seen the video, but you probably will pick up stuff. You can actually watch it after Thursday because we will in class be doing a page that looks just like it. So it more has to do with how time works. So there is going to be another video that shows up to watch if you have the time to watch it and try this page before Thursday with the video. Yeah, because again, usually this class had more hours and they didn't want me to do that. All right, empirical formula from combustion. So the trick for step 1, again, this was like the bonus on the lab, is you start with the grams of CO2 and you solve for grams of carbon. And that is because in combustion of a hydrocarbon, we assume all the carbon becomes CO2. It is an actual assumption because most combustions also make some carbon monoxide in there, but we're going to assume all of the carbon became CO2. So now we're just working back. We do have to go to grams because of step 3. So grams to moles. And CO2 is like 44. That step is from the periodic table, adding up a carbon plus 2 oxygens. In CO2, there is only 1 carbon. So we just show a 1-to-1 mole ratio. And then 1 mole of carbon, 12.01 grams. And you should get 0.164 grams carbon. So to find the carbon, you always go from the CO2 to the carbon. Right? To find the H2O, we're going to go from, to find the hydrogen, we're going to single elements, right? It's empirical formula. We're going to go start with the H2O. So that pen doesn't show up. So H2O is like 18.02, 18.016. That's like a personal preference. Label, which actually, remembering from looking at the labs, most of you did that really nice. And there are a couple of you who haven't turned in the lab. You should be able to do the bonus now after watching this part. This is the step that a lot of you missed. So actually like half of you. And that is you forgot the mole to mole step. There are 2 moles of hydrogen. We are doing empirical formula. We're going down to single elements. We're not doing diatomics. We'll talk about diatomics on Thursday. And then every 1 mole of hydrogen is 1.008 grams. And we punch that in and we'll get 0.0182 grams of hydrogen. This is the most missed step on these problems, is remembering to do that ratio. All right, so for step 3, the oxygen is a subtraction. And the reason is in combustion, did we do on the study set, we had combustions like this one. The oxygen ends up everywhere. The oxygen's all over the place. So how do we know which oxygen? Is it the CO2 oxygen? Is it the H2O oxygen? Which oxygen is it? And in fact, vitamin C itself has some oxygen in it. So which oxygen are we talking about? So you always go back to the original formula, the 0.400 grams of the original compound. I'm just going to write it like that because that was a question. A couple of you emailed me and said that you were stuck. You weren't sure which compound I was talking about. The CO2 and the H2O are products. We're just working them back to get to the carbon. And then you subtract the carbon answer here, the 0.164 and the 0.182 grams. The 2 most missed things on this problem is this mole to mole ratio. So it's there now, you guys won't miss it. The other thing is the zeros. And several of you are probably smiling, listening because you did this. There's always lots of zeros, so make sure you have your decimal place obvious. Make sure you keep 3 non-zero digits, 3 or 4 non-zero digits. So these zeros are not significant, they're placeholders. They're very important, but we don't count them in sig figs. We punch that in and we get our 0.218 grams of oxygen. Again, I like to put the X there. We are not doing diatomics here. This is not about O2. This is about the compound carbon, hydrogen, oxygen. Now we do empirical formula. So we take the 0.164 grams of carbon, the be careful to write them how you had it, the 0.0182 grams of hydrogen and the 0.218 grams of oxygen. Now, something a couple of you did, which you could do, but it's an extra step. It's not necessary. You actually went back to percents and then to moles. You don't have to go to percents. If you're at grams, just go from grams to moles. So periodic table. Now, a question that often comes up, so we go back. Some of you like YouTube, and that's great. And YouTube will show you another way to do this. It doesn't work on this. So students are like, why can't I just stop at moles here? Why do I have to go to grams? Because I'm going back to moles. Empirical formula is all about moles. So why did we have to go to grams? It's your last bonus question of the night. Actually, there is another bonus question. Anybody know why I had to go all the way to grams? I couldn't just stop at moles since it's empirical formula. Because we had to subtract. And when we did the subtraction step, it was grams. So we had to get all the way to grams of carbon, all the way to grams of hydrogen to be able to subtract. Whenever you do a subtraction step, whether it was this problem or the limiting reactant problem, you need to label what is happening in the subtraction. So please make sure you label fully. We do the hydrogen, we do the oxygen. Anyway, you guys know what to do, and then you divide by the smallest. And the ratio you're going to get is 1, 1.33, and 1. So when you divide by the smallest moles. So what number would we multiply by to make them whole numbers? You can't just say, oh, they're all close enough to 1. So we get 1, 1.33, and 1. We're going to multiply by 3. Yeah. So you end up with C3H4O3 as our answer here. I won't go through, I didn't show every single step there, but I think you guys can do it, or you can come and ask me if you get stuck. There's one of these on the study set. There was one on the lab, the bonus on the lab, and there's one on the worksheet. I want to go through the last problem just briefly. So here's the bonus. What other piece of information would you need to be able to find the molecular formula? So this is the empirical formula. What's the other piece of information we need?
Molar mass.
It is. Who said that?
Daniela.
You already got a bonus. You actually get a double bonus because you answered my email. Yeah, so the molar mass and divided by the empirical mass, which means of the C3H4O3. The molar mass needs to be given, and then we could figure this out. The one on the lab, the bonus page, actually, I gave you that so you could do that step. All right, I'm going to stop unless there's a question. And